All right. Which of the following is a solution to this differential equation with the initial value condition y of pi equals 1? So there's a couple options here. I'm going to be really honest. One really solid first option is to just plug in pi for all these and see which ones give you a 1, because a bunch of them won't. And if you spot that, right, you could be like, cool. So like, for instance, you could start here. You could be like, cool, I'm just going to knock some of these off because I don't even care. And that's fine, right? If you tried plugging this in, if you cosine of pi, right, it is worth noting that the cosine of pi is a -1, which we should know, right? We should know pi is over here and the cosine is -1. So if you tried this point here, this would be a -2 plus 3, which does come out to be a 1. This would be a -2 minus 1. It's not B. This would be a +2 plus 3. It's not C. This would be a +2 plus 1. It's not D. And this would be a +2 minus 1, so it could be E. Just by plugging in that point, I've knocked it down to 2 possible answers, which is pretty dope. Beyond that, I'm straight up just integrating. If you know how sine and cosine integrate, so this side's going to be a y, right? If you integrate, so derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine. So this is deriving, right? That's a negative. Sorry, kind of blended in with my arrow. And this is integrating, right? So if you're integrating sine, you're going to get a negative cosine. If you know that, then you know it's E, right? Now, I don't care if you wanted to straight up integrate first, right? You could have, like, this is the mathier root, right? And then you could have plugged in 1 equals -2 cosine of pi plus C. You would have gotten 1 equals 2 plus C. -1 is your C. Oh, look, there's your answer. But again, it's not always about solving the whole problem. It's about knocking off answers and moving on.